and the numerals on the vertical axis, which represent the value of the object. Here, the scale is 1 unit equals rupees 10. This means that 1 unit of length is for rupees 10. To show the value of the objects, bars of uniform width are drawn vertically with equal spacing, uniform distance between them. These are called bars. It is not necessary that the bar graph should be vertical. Instead, by interchanging the positions of the horizontal x-axis and the vertical y-axis, we can also show the bar graph horizontally. The length of the bar represents the given number. Like here, we can say that the first bar denotes the value of the book as rupees 80. The second bar denotes the value of the notebook as rupees 18, while the third bar denotes the value of the chocolate as rupees 2. Thus, we can say that the graphical method of representing the data where bars of uniform width are drawn horizontally or vertically with equal spacing between them, and the length of each bar represents the given number is called a bar diagram or a bar graph. Just think, what all information you can collect from a bar graph. Absolutely right. With the help of a bar graph, we can obtain different types of information. For instance, to find the number, to compare, etc. Today we learned about bar graph. In the next video, we will learn how to draw a bar graph. Today we will learn how to draw a bar graph. We will learn with the help of an example. Suppose the following table was prepared to find the most preferred spot based on the choice of students in a class. Let's represent these figures in the bar graph. Although we can draw bar graphs on blank paper, the use of graph paper makes it more convenient. Let us use graph paper. Step 1. On a piece of paper, draw two perpendicular lines where line OX is a horizontal line and line OY is a vertical line. Step 2. Along the horizontal line, we will write the names of the spots mentioned in the table, keeping uniform distance and write spots under it. In this way, we will show the spots on the horizontal line. Similarly, along the vertical line, we will mark the corresponding number of students. Step 3. Next, we will choose suitable scale along the vertical line. Here, 1 unit length represents 5 students. Therefore, we will choose the scale as 1 unit length is equal to 5 students. You can choose a suitable scale based on the number such that if the number of students is very less, then you can take 1 unit length is equal to 1 student. Similarly, if the number of students are large, then you can take 1 unit length is equal to 10 students. Remember, the scale provides us with the convenience to draw a bar graph. Since we have taken the scale 1 unit length is equal to 5 students, we mark multiples of 5 along the vertical line to represent the scale as 1 unit length is 5 students. The length of 2 units represent 10 students. Therefore, the number of students can be calculated by 5 multiplied by number of units. With this, we can also find the number of units by dividing the number of students by 5, which is the length of the bar. Step 4. So, let's find the length of the bars. Cricket, 20 divided by 5 is equal to 4 units. Football, 15 divided by 5 is equal to 3 units. Kabaddi, 25 divided by 5 is equal to 5 units. Tennis, 10 divided by 5 is equal to 2 units. Step 5. Now we will draw the bars of uniform width for different sports at a uniform distance. For instance, for cricket, we will draw a bar of 4-unit length. Next, for football, we will draw a 3-unit length bar of the same width, keeping uniform distance. Can you tell us, how will we draw a bar for Kabaddi? Think for a while. Absolutely right. Once again, we will draw a 5-unit length bar of same width, keeping a uniform gap between them. Similarly, for tennis, we will draw a bar of 2-unit length. This is how we obtain a bar graph. Remember, it is not necessary that a bar graph has to be vertical. Same data can be represented by interchanging positions of games and number of students. We can also show the bar graph horizontally. Looking at this bar graph, one can easily tell that Kabaddi is the most preferred sport in the class. Although we can draw a bar graph on a blank paper, the use of a graph paper provides convenience to draw a bar graph. Will you be able to illustrate this data using a bar graph on a graph paper? Try yourself. Today we learned how to draw a bar graph. In the next video, we will see some examples related to bar graph. Today we will see some examples related to bar graph. A bar graph is shown below. This graph refers to the sale of apples made by a fruit seller from Monday to Saturday. Read the graph and answer the following questions. First question. 1. What is the scale of this bar graph? We observe that here the scale is 1 unit length is equal to 1 kg. Second question. On which day were the maximum number of apples sold? In the given bar graph, we observe that the bar on Thursday is the longest. So we can conclude that the highest sale of apples were made on Thursday. Third question. How many kilos of apples did the fruit merchant sell on Monday and Tuesday? Monday is marked by 9 unit lengths of a bar and Tuesday by 10 units. Here we are given the scale 1 unit length is equal to 1 kg apples, which means 9 kgs of apples were sold on Monday and 10 kgs on Tuesday. To calculate the total sale made on Monday and Tuesday, we will add the total sale made on both days, which will result in 19 kgs. From this, we can infer that the fruit merchant sold 19 kgs of apples on Monday and Tuesday. Next example. Following table shows Marks obtained by Arnav from class 6 to 10 in percentage. Draw a bar graph to represent the following information, choosing the scale of your choice. Step 1. On a piece of paper, draw two perpendicular lines where line OX is a horizontal line and line OY is a vertical line. Step 2. Along the horizontal line, we will mark the class, and along the vertical line, mark the corresponding marks. Step 3. Next, we will choose a suitable scale along the vertical line. Here, 1 unit length represents 10%. Therefore, we will choose the scale as 1 unit length is equal to 10%. Step 4. Next, we will find the length of the bars. For class 6, length of the bar will be 60 divided by 10 is equal to 6 units. In the same way, we can find the length of the bar for class 7, class 8, class 9 and class 10. Step 5. Now we will draw bars of uniform width for different classes at a uniform distance. For instance, for class 6, we will draw a bar of 6 unit length. Next, for class 7, we will draw a 7 unit length bar of same width, keeping uniform distance. Similarly, for class 8, we will draw a bar of 7 unit length. Now, can you tell how will we draw a bar for class 9? Think for a while. You are absolutely right. 7.5 means 7 full units and 0.5 units means 5 parts out of 10 parts of 1 unit. Therefore, for class 9, we will draw a bar of 7.5 unit length in this way. In the same way, we will draw a bar of 8 unit length for class 10. Thus, we have obtained a bar graph for the given information. Today we saw some examples related to bar graph. In the next video, we will see some misconceptions and common mistakes related to this. Today we will see some misconceptions and common mistakes related to bar graph. Misconception 1. Find out which of the following is a bar graph. Here, the bars drawn in figure 1 are horizontal and the bars drawn in figure 2 are vertical. Some students believe that a bar graph can only be drawn vertically, not horizontally. Due to this misconception, they believe that figure 1 is not a bar graph. Instead, figure 2 is a bar graph. With this understanding, they choose option 1 as their answer to the given question, but this is an incorrect answer. The correct understanding is that in a bar graph, bars can be drawn either vertically or horizontally. Therefore, a bar graph is shown in both figures. Thus, option 2 is the correct answer. Misconception 2. A bar graph is given below. This graph shows average rainfall experienced in a village between the months of June and September. Read this graph and find out how much rain did the village receive in the month of September. Some students ignore the unit given in the bar graph and answer by counting only the box. Like here, they obtain the answer 9 mm, which is a wrong answer. Hence, option 1 is the incorrect answer. The correct understanding is that it is important to pay attention as to what scale is chosen when receiving information from the bar graph. For instance, here 1 unit is equal to 100 mm, meaning 1 unit length represents 100 mm rain. The height of the bar for September is 9 units, which means the month of September received 9 multiplied by 100 mm is equal to 900 mm rain. Thus, option 2 is the correct answer. Now let us understand some of the mistakes made while drawing a bar graph with the help of an example. Question. Observe the table given below, which shows the total number of TVs sold by a shopkeeper in different years. Choose a scale of your choice and illustrate this data using a bar graph. Mistake 1. Some students fail to choose a suitable scale while choosing the scale of a bar graph. Suppose they try to draw a bar taking 1 unit length is equal to 100 TV. They thus obtain lengths of bar and attempt to draw a bar graph. Even though they succeed to form the bar graph correctly, but due to the length of the bars being too small, they face a lot of difficulty while drawing the bars. Here, we observe that all the numbers of multiples of 10. So, we can take 1 unit length is equal to 10 TV. This will give us the length of the bars. Therefore, in this way, we can easily draw a bar graph. Mistake 2. Some students fail to label the horizontal line and vertical line of the bar graph. Similarly, they fail to write scale. Apparently, they do not consider it important enough to label the lines or write the scale, or they simply forget to write them. Due to such simple mistakes, it becomes difficult to obtain the desired information from a bar graph. Therefore, it is necessary to show the scale on the bar graph as well as the proper names of what is being taken on the horizontal and vertical lines. Mistake 3. Some students fail to maintain a uniform width while drawing a bar. Similarly, some students fail to keep a uniform distance between the bars. We should keep in mind that the bars are of uniform width and that there is a uniform distance between the bars. Today we saw some misconceptions and common mistakes related to a bar graph. Today we will learn classifications of triangles. Let's start this video with an interesting question. Here are some figures. Can you identify which of these figures is a triangle? You may pause the video and try to find out. Have you chosen figure E? If yes, then congratulations! You have correctly identified the triangle. To correctly identify a triangle, it is important to understand its concept correctly. Triangle is made of tri plus angle, which means a figure that is made of 3 sides. Therefore, we can say that a figure that is made up of 3 sides is called a triangle. In the given figures, only E is made up of 3 sides. Therefore, only this is a triangle. Along with 3 sides, a triangle also has 3 angles. In different triangles, we see that the measures of sides and angles are different. To understand triangles better, we classify them on the basis of their sides and angles. So let's first learn the classification of triangles based on the sides. Look at this triangle. If we take the measurement of its 3 sides, then we will know that all its 3 sides are not equal. Such triangles whose sides are not equal are called scalene triangles. If we take the measurement of its angles, then we will know that its angles are not equal. In this way, we can say that all 3 sides of triangle are not equal, then its angles are also not equal. Now look at this triangle. If we take the measurement of its sides, then we find that 2 sides of its sides are equal and the third side is not equal to its other 2 sides. A triangle whose any 2 sides are equal is called an isosceles triangle. If we measure its angles, then we will know that the angles opposite to equal sides are also equal. This means that 2 sides and 2 angles of an isosceles triangle are equal. Now, look at this triangle. On measuring this triangle, we find that all its 3 sides are equal. A triangle whose 3 sides are equal is known as equilateral triangle. If we measure its angles, we find that all the angles of such a triangle are also equal. That is, all the sides and all the angles of an equilateral triangle are equal. Now, let's learn how to classify triangles on the basis of angles. Here, 3 triangles are given. Can you find any difference by looking at their angles? Try. If we look at triangle ABC, then all its angles are acute angles. If we look at triangle PQR, then it has 2 acute angles, but 1 right angle. Similarly, in triangle LMN, we can see that there are 2 acute angles, but 1 obtuse angle. With this understanding, we can classify the triangles in following ways. Triangles in which all angles are acute angles are called acute angle triangle. Triangles with 1 right angle are called right angle triangle. Remember that the right angle of a right angle triangle is represented like this. Therefore, if an angle in a triangle is given like this, then you can easily identify that triangle as a right angle triangle. Similarly, triangles in which 1 angle is obtuse angle is known as obtuse angle triangle. Today we have learned classification of triangles. In the next video, we will learn some examples related to this.
The festivities are in the air and the preparations for it had already started at Sunaina's house. Her uncle brought the decorative items and her mother started preparing for the food items. Dad started cleaning the house. Amidst all of this, Sunaina was walking around with a doll in her hand. She saw her cousin brother Mukul playing and asked,
"Where is Auntie Mukul?"
Sunaina Didi, Ma is stitching in her room.
As soon as she heard this, Sunaina ran to her auntie.
Auntie, will you help me?"
Yes, Sunaina, I will do it. What is the matter?
Festivals are approaching and everyone is bringing new clothes at home. I want my doll to wear new and colorful clothes too. I will need your help in this.
I have stitched many clothes now. There is a lot of clipping left in them. We can make new clothes for your doll by the leftover clippings. Take this bag full of clippings. Pick whatever you like from it.
Oh wow! There are many colorful clothes in it.
Yes, Sunaina. It has different types of fabrics such as cotton, silk, and synthetic. You can make a frock or salwar kameez for your doll from any of them.
All these clothes are so beautiful. Auntie, how are such beautiful clothes made?
Sunaina, India is famous all over the world for making different kinds of clothes. The dress of each province of India is different, and the clothes which are made there are also of different types. Cotton, silk, velvet, woolen. All kinds of cloth are made in small factories and workshops. Sunaina, if you look at the clothes carefully, then you will know that every cloth is made up of weaving threads.
Oh yeah, it looks like a thread mat. Auntie, if the cloth is made up of thread, then where do these threads come from?
To answer this question of Sunaina, her auntie removes thread from her sewing machine and scratches it into thin parts and shows it to Sunaina. Sunaina, these thin hair-like strands which are coming out of this thread are called fibers. Threads are made from these fibers and then fabric is produced from them.
This is very interesting. I will tell my friends about this. But auntie, I have never seen the fibers around. All these produced a particular place.
Sunaina, the fibers which are used to make different types of clothes are found in different places. We get fiber from plants and animals. Examples of fibers that we get from plants are cotton and jute. Silk and wool are the examples of fibers obtained from animals. These types of fibers are known as natural fibers. Earlier, clothes made of natural fibers were used. But from few years, fibers are also being made using chemical materials. These are called synthetic fibers.
Auntie, what type of cloth is made using such fibers?
They produce fabrics such as nylon, polyester, and acrylic. Sunaina, now look around yourself and find things that have clothes made using natural fibers.
The sari you are wearing looks like a cotton cloth. So this is an example of garment made up of natural fibers. And this tablecloth, it appears to be a fabric made up of synthetic fibers.
Absolutely correct, Sunaina. This tablecloth is made of nylon. Auntie also made a beautiful frock for Sunaina's doll, which made Sunaina very happy. Sunaina thanked her aunt and dressed the doll in her new clothes. Then Sunaina ran to her friends.
Samina, Mohan, Subir, look how beautiful frock my auntie made for my doll. And sitting with my aunt today. I also learned a lot about clothes.
Really? Tell us too, Sunaina.
I came to know that the clothes we wear all made up of threads, and threads are made of even thinner elements called fibers.
What is fiber?
Remember the day when we were playing catch up and you fell down? Your pants got torn from the knee. At that time, some thin threads come out of the torn area. There are fibers. Fibers are of two types. One is natural, which we get from plants and animals. And the second one is synthetic, which is produced from chemical substances.
Yes, I have also heard about this from my father. He works in a clothing factory.
Oh wow! Why don't we ask him how the fabric is made from fibers? Good idea. Let's go.
And then all the children ran towards Mohan's house to learn more about clothes.
Today we will see misconceptions related to associative property of integers. Misconception 1. Puneet and Priya have to find the value of the subtraction of minus 34, 25 and 4. Puneet has solved it by making a group of minus 34 and 25 and obtained the result minus 63. Priya has solved it by making a group of 25 and 4 and obtained the result minus 55. Tell me who is correct. While performing the subtraction of integers, sometimes the fact integers are not associative over subtraction is ignored. That means for any integers a, b, c, a minus b minus c is not equal to a minus b minus c. In this example, Priya made a group of 25 and 4 and solved it. She obtained the result as minus 55, which is an incorrect answer. The correct understanding is that while performing subtraction of integers, first two integers have to be subtracted and the third integer has to be subtracted from the result. Therefore, Puneet's answer is correct. That means the correct answer to the given question is option 1. Misconception 2. After teaching associative property of integers, the teacher gave a question for homework. What is the value of minus 312 divided by 6 divided by 2? Sandhya has obtained the answer as 104 and Varun has obtained the answer as minus 26. Who is correct in your opinion? Sometimes students ignore the fact that integers are not associative over division. That means for any integers a, b, c, a divided by b divided by c is not equal to a divided by b divided by c. They think that it will be easier to divide 6 by 2 instead of dividing minus 312 by 6. That's why they divide 6 by 2 and with the result 3, they divide minus 312. By doing so, the result obtained is minus 104. This is a misunderstanding. Integers are not associative over division. Hence, to solve the given example, we cannot make a group of 6 and 2. To solve this, first, we have to make a group of minus 312 and 6. The result of this group is minus 52. Then, we have to divide minus 52 by 2. By doing so, the correct result is minus 26. Therefore, we can say that Sandhya has given an incorrect answer and Varun has given the correct answer. Misconception 3. Sudhir and Nayan are solving the expression minus 16 multiplied by 2 multiplied by 5. They solved it in the following way. Find out who is correct. Sometimes, students multiply the numbers inside the bracket with the number outside it. This is an incorrect understanding. Solving it this way, Sudhir obtained a wrong answer. The correct understanding is that first we will solve the expression inside the brackets and with the result obtained, we'll multiply the number outside the brackets. By doing so, Nayan has obtained the correct result. Today we have seen misconceptions related to associative property of integers.
Today we will learn bar graph. Numbers from which information can be collected are called data. Here, data is shown in numerical form. Let's represent this information in a pictorial form. We can make a pictograph or bar graph. We have learned about these in previous class. Let's discuss a bar graph. Bar graphs are a way of representing numerical data in a pictorial form by creating bars of equal width at equal distances. The length of each bar in the bar graph displays the given number. We can draw the bar graph either horizontally or vertically. The number of students coming from different colonies in a school are shown in following table. Let us display this data in the form of a bar graph. First, we will draw the x-axis and the y-axis. Now we will show various categories on the x-axis, like here, name of colonies. We will show the number of students on the y-axis. We will take a convenient scale to represent numerical data correctly. Here, we can take this scale as 1 unit is equal to 9 students. Because all the numbers are multiples of 9, so we will be able to represent these numbers. In this way, we will show the numbers 0, 9, 18, etc. on the y-axis. The maximum value here is 54, but for our convenience, we have taken numbers up to 63 on the y-axis. Now, we will draw a bar. In the bar graph, we represent the data in the form of bars. The number of students coming from colony 1 is 36. So, we will draw the bar in such a way that its length should be numbered 36. In the same way, we will draw bars of equal width for all the colonies at equal distances. Thus, we have drawn the bar graph to show the number of students coming from different colonies in the school. This is a vertical bar graph. We can also draw it horizontally like this. Now, observe the bar graph. Can you tell me maximum number of students come from which colony? Just by looking at the graph, you will be able to tell that maximum number of students come from colony 2. In this way, the bar graph helps us to get the information by looking and comparing data. Now, find out yourself what kind of information you can collect from this bar graph. Today we have learned the bar graph. In the next video, we will learn double bar graph. Today we will learn double bar graph. In the previous video, we have learned the bar graphs. Now, let's learn the double bar graph. Here we are given total number of students and girls from different cities. Let us represent this data in different way. If we draw different graphs for both these tables, we can get information such as maximum number of girls came from which city. But if we are required to get combined information like which city has all girl students, then how we can find it? Think. We cannot get combined information from different bar graphs. Here, the number of students and the number of girls are related to each other. In such a situation, if we represent both types of data together in pictorial form, then it will be more convenient for us to understand the data. This feature provides us with a double bar graph. Drawing a double bar graph is very similar to drawing a bar graph. First, we will draw the x-axis and the y-axis. Now we will show various categories on x-axis, like here, name of cities. On the y-axis, we will show the number of students. We will take a convenient scale to represent the numerical data correctly. Here we can take this scale as 1 unit is equal to 9 students. Because all the numbers are multiples of 9, so we will show the numbers
0, 9, 18, etc. on the y-axis. The maximum value here is 54, but for our convenience, we have taken numbers up to 63 on the y-axis. Step 4. Now we will draw a graph. We will denote the number of students coming from city 1 and the number of girls with a pair of bars in which one bar will represent the number of students and the other bar will denote the number of girls. Similarly, we will show the number of students coming from all the cities and the number of girls in pictorial form. Remember that we will keep the same width of each bar and keep the same distance between the pair of bars made for different cities. This will give us double bar graph. Now, you can draw a double bar graph either horizontally or vertically. You can get various information from this double bar graph. For example, the number of girls coming to school from city 3 and city 4 are equal. In the same way, we can also get combined information like the number of students coming to school from city 4 and number of girls are equal. Try yourself to get more similar information. In this way, with the help of double bar graph, we can compare two types of data related to each other and get different types of information. Today we have learned double bar graph. In the next video, we will see interesting examples related to the bar graph and double bar graph. Today we will see some interesting examples related to bar graph and double bar graph. The bar graph shown depicts the number of patients visiting a hospital. Read the bar graph and answer the following questions. On which day the number of patients coming to the hospital was minimum? The number of patients coming to the hospital on different days are indicated as the length of the bar in the graph. In this way, the bar which has the shortest length will give us the answer to this question. We see that length of bars showing the number of patients on Sunday and Tuesday is same and is smaller than length of the all bars. So we can say that the least number of patients come to the hospital on Sunday and Tuesday. What is the total number of patients coming to the hospital on Monday, Wednesday and Thursday? Based on the length of the bars, we can say that in the hospital, 22 patients visited on Monday, 13 patients on Wednesday and 15 patients on Thursday. In this way, the total number of patients coming to hospital on Monday, Wednesday and Thursday is 22 plus 13 plus 15 is equal to 50. Now find yourself the difference in number of patients who came to the hospital on Saturday and Friday. Next example. The following table shows electricity bills of Rohit and Mohit for different months. Represent the information in the double bar graph. Observe the statistics. Can you tell me what would be the convenience scale here? Think. Let me tell you, the smallest number here is 950 and largest number here is 1600. So here we do not have to start from 0, but we can take numbers from 900 to 1700. We will draw a zigzag line to show that we are not showing numbers from 0 to 900. It will be easy to use this scale as there is no number from 0 to 900. We can take 1 unit is equal to 100 rupees as scale. Similarly, we can also take this scale as 1 unit is equal to 200 rupees. Let us take 1 unit is equal to 100 rupees scale and show the electricity bill on the y-axis in rupees. Similarly, months will be indicated on the x-axis. We will draw this type of bars for Rohit and this type of bars for Mohit. Now, we will show the bills of Rohit and Mohit in the month of June by drawing the double bar. Similarly, we will draw a double bar graph for all months. Read the given bar graph and find out the information in the double bar graph. To find out what information is shown in this bar graph, one has to look at what is represented on x-axis and y-axis, along with understanding what each bar represents in a pair of bars. The double bar graph shown is the horizontal double bar graph. Here, names of subjects are shown on the y-axis and the marks are shown on the x-axis. The red color in the pair of bars indicates Rahul's marks and green bars indicates Vishal's marks. Therefore, we can say that this double bar graph compares the marks obtained by Rahul and Vishal in various subjects in an examination. Which subject do you think Rahul needs to pay more attention to? Rahul's marks are denoted by red bars. The shortest length of all red bars is drawn for English subject. This means that out of all the marks of Rahul's subject, he got lowest marks in English. Hence, Rahul have to focus more on English subject. So today we have seen some interesting examples related to bar graphs and double bar graphs. In the next video, we will see some common mistakes related to them. Today we will see some mistakes related to bar graph and double bar graph. Mistake 1. Students often have difficulty in choosing the right scale when drawing a bar graph or a double bar graph. Like here, the number of students present in the class on Monday, Tuesday and Wednesday are shown. Children often think that it becomes easier to draw a bar graph if the scale is considered as multiple of 5, 10 and multiple of 10. But this is a misconception. Here we see if all the numbers are multiples of 6, therefore it will take 1 unit is equal to 6 students. Then it will be very easy to draw the bar graph. But if we take the value of the unit as 10, then it will be difficult to represent the numbers shown. It will also increase the chances of mistakes. Can you tell what scale can we take here instead of 1 unit is equal to 6 students? Think. We can also take this scale as 1 unit is equal to 3, 4 or 12 students. Actually, it is not necessary that the given numbers are always multiples of a single number. In such a situation, we choose the scale that allows us to represent more and more numbers. Mistake 2. Some children have difficulties in finding out what information is given in the double bar graph. For example, if they are asked what information is shown in double bar graph, then they are not able to answer it. To find out what information is shown in a double bar graph, it is necessary to look at what is represented on the x-axis and the y-axis, as well as understanding what each bar represents in a pair of bars. Here, the number of ice creams sold is shown on the x-axis and the days are shown on the y-axis. Here, the brown bar represents the number of chocolate ice cream and the pink bar represents the number of strawberry ice creams. With this understanding, we can say that sale of chocolate and strawberry ice creams on different days has been compared in double bar graph shown. So today we have seen some mistakes related to bar graph and double bar graph. Today we will learn about chance and probability. Let us understand these concepts by considering some situations. Here is a bag in which there are 3 red balls. If we take out one ball without seeing in it, will it be a red ball? Think. Absolutely right. Here, without seeing these 3 red balls, getting one red ball is certain. Is it also certain that if we draw out one ball from 3 red balls without seeing in it, then it can be a green ball? Think. Definitely, your answer will be no, because taking a ball without seeing 3 red balls and getting a green ball is impossible. Now look here. Here is one coin. Can you tell whether we will get a head or a tail in the experiment of tossing the coin? Think. Here we certainly cannot predict whether we will get a head or a tail. In such a situation, getting one from either of these two is a possibility or a chance, because these both are possible outcomes. But in this situation, the possibility of getting a head and the possibility of getting a tail are equal. In such a situation, we say that the outcomes are equally likely. Here, both head and tail are equally likely outcomes. Here we have done an experiment of tossing the coin, the outcome of which can be head or tail. Each outcome of an experiment or a collection of outcomes forms an event. Like here, getting head is one event, and similarly, getting tail is also one event. When a coin is tossed, then the outcome can be either a head or a tail. We will represent head with H and tail with T. In this way, we can say that all the outcomes of the experiment of tossing the coin are HT. The possibility of getting of each from these is 1 out of 2, that is 1 by 2. We say that probability of getting head is 1 by 2 and the probability of getting a tail is 1 by 2. In this way, probability tells us that what is the possibility of happening of any event. In this way, probability helps in measuring the possibility. In standard form, probability of an event is equal to number of favorable outcomes of event divided by number of possible outcomes of an experiment. For example, the number of all possible outcomes when a coin is tossed is 2 and number of outcomes favorable to the event of getting the head is 1. So, the probability of getting head is 1 by 2. Now, look at this spinner. It has yellow, red, green, pink and blue colors with equal areas of paths. Can you tell what would be the possibility of stopping the spinner at pink color when it is spinned? Think. Let us tell you. Here, the area of all colors is equal. That's why the possibility of results will be equal. That is, outcomes are equally likely. In this experiment, there are total 5 possible outcomes. But Out of these 5, favorable outcomes is only one, pink color. In this way, on spinning the spinner, the possibility of stopping at pink color is 1 out of 5. We say that on spinning the spinner, the probability of stopping at pink color is 1 by 5. If the outcome of event is certain, the probability of that event is 1, and if the event is impossible, its probability is 0. Like in a bag containing all the red balls, if a ball is taken out, then it will be a red ball. So, the probability of getting a red ball is 1. But it is absolutely unlikely to be a green ball. So, the probability of getting a green ball is 0. But when the event is likely to occur, then the probability is greater than 0 and less than 1. Now you must have understood probability. So, today we have learned about chance and probability. In the next video, we will see some interesting examples related to chance and probability.
Heat Part 2. Hello friends, how are all of you? I have had fever for the last few days. I checked my fever on a clinical thermometer and the reading was 100 degrees Celsius, which is approximately 2 degrees higher than the normal reading. Do you remember the normal human body temperature? The normal human body temperature is 37 degrees Celsius or 98.4 degrees Fahrenheit. I'm sure all of you now know about the use of the thermometer. But can we measure the temperature of hot water with a clinical thermometer? I want to know that. Why do hot things become cold and cold things become warm? Let us look for answers to a few such questions through this story. The objectives of this video are 1. To understand about laboratory thermometer. 2. To understand how heat flows. 3. To understand what are conductors and insulators.
Ravi, drink the milk or it will become cold.
Mother, this milk is still so hot. Can you please make it cold for me? Mother, can we measure the temperature of this milk with a clinical thermometer?
No, Ravi, it can be dangerous. Clinical thermometer is used only to measure body temperature. To measure the temperature of water, milk or the weather, we use the laboratory thermometer.
You kept this hot glass of milk in a bowl of cold water. And look, it has become cold in some time. But look, now this water has become warm. Does it mean that heat flows from hot object to cold object?
Yes, you are right, Ravi. Heat flows from hot object to cold object.
Oh, is that the reason my ice cream melted yesterday?
Yes, children, heat flows from a hot material to a cold material.
Ravi, I brought your science book back. I have a lot of doubts. I will have to ask the teacher a lot of questions tomorrow.
Why? What happened? Why did you not understand?
I have doubts in the chapter on heat.
Ravi, can you please stir the vegetable on the gas with the spoon?
Oh, this spoon is so hot.
There is a wooden spoon. Use that.
Oh, this wooden spoon did not get hot, but that steel spoon had become so hot.
Yes, there is mention on the same in our science book too. But what could be the reason for this?
Ramesh, let us do an experiment. Let us take different objects made up of different materials. Then let us dip them in hot water one by one. Let us then observe what happens to each object.
Children, I shall warm the water and give it to you.
Look, Ramesh, I have this wooden spoon, steel spoon, this pair of scissors, this plastic scale, and this ceramic spoon. Come, let us dip all of them in this hot water.
Look, Ravi, this steel spoon has become so hot, and this wooden spoon, plastic spoon, and ceramic spoon haven't become hot.
This pair of scissors made of iron has become so hot. Yes, Ramesh, I have also noticed that when we play on the slides in the park, the slide made of iron becomes so hot.
So, it means that some materials like wood, plastic, etc. do not let heat pass through it?
And materials like steel, iron allow heat to pass through them.
Good observation, children. The materials which let heat pass through them are good conductors of heat and are known as conductors. The objects which do not allow transfer of heat are poor conductors of heat and are known as insulators.
Oh, that is the reason a few utensils have plastic handles. Because if the utensil contains something hot, the heat does not transfer to the handle and we do not burn our fingers.
Yes, you are right. The sun also gives so much of heat, and because of that, the air and water in rivers and sea becomes hot. So are air and water conductors or insulators?
Friends, we learned that heat is transferred from a hot to a cold object. The materials which let heat pass through them are known as conductors, and the materials which do not allow heat to pass through them are known as insulators. Ravi asked a question. What could be the answer to that? Are air and water conductors or insulators? We shall look for the answer to this in the next video. We shall meet soon. Heat, Part 3. The objectives of this video are 1. To understand about convection. 2. To understand about natural convection in coastal regions. 3. To understand why do we wear clothes according to the weather. Hello friends, how are all of you? I had been to Goa for a few days. Goa is a beautiful beach destination in Maharashtra. How is it that a beach always has a pleasant atmosphere? Have you ever thought that why do we wear light colors in summers and dark colors in winter? Come, let us find the answers to such questions with the characters of this story, Mala and Raja.
Mother, I want hot water to take a bath. Can you boil some water for me?
Yes, Raja. Wait for a while till the water heats up.
Mother, the water close to the flame heats up faster, right?
Yes, Raja.
Then all of the water heats up together.
Like you said, that the water near the flame heats up first. Then it rises up. Then the cold water around it takes its place. Then similarly, the water heats up and rises. This continues till the whole water in the vessel heats up. This is known as convection.
Is convection also a method of transfer of energy of heat like conduction?
Yes, you are right, Raja. Convection takes place in liquids and gases.
The air also heats up because of the sun's heat. So, does it also rise like water?
Shall we do an experiment? We will need these materials: a broad cylindrical glass tube, one candle, one incense stick, one round cardboard with 2 holes, tape, matchbox. Come, let us light the candle and place this broad glass tube over it. Now cover the glass tube with the cardboard and secure it with the tape. Remember to place the cardboard in such a way that one hole is right on top of the flame of the candle. Now light the incense and place it over the other hole. Now let us wait and watch what happens.
Look, the smoke from the incense stick is coming out from hole above the candle.
Yes, but how did the smoke from the incense go inside the glass tube?
Think.
The hot air around the candle is coming out and the cold air from around the incense stick is going inside.
And then the air which went inside is becoming hot and rising from the other hole.
Good job, children.
This means that hot air rises and the cold air takes its place.
Mala, do you remember that in the science exhibition in school, a child had made a model in which he had explained something about the similar flow of air around the seaside?
Yes, I remember, but not clearly. Come, let us read in our science book. Look, it is written here that during the day the land heats up faster than the water and the air above it rises. To occupy that space, cold air from the sea comes in and takes its place. This is known as sea breeze. During the night, the opposite happens. Water in the sea cools down slowly than land, and therefore cold air from the land flows towards the sea, and warm air from the sea comes and takes its place. This is known as sea breeze.
This explanation is exactly like the experiment we just did. Like the cold air from near the incense went in and the hot air rose up from above the candle. Likewise, the currents around the seaside are examples of natural convection. The sun also gives us heat, but there is no medium between the sun and the earth. So then, how does the heat from the sun reach us?
Yes, a medium is required for transfer of heat in conduction and convection. So how does transfer of heat take place without a medium from the sun? Come, let us look in the book. Look, it is written here that the heat from the sun reaches earth through radiation.
Radiation? Show me the book. It is also written here that there is no medium needed for radiation. That means transfer of heat takes place by 3 means: conduction, convection and radiation.
Raja, wear something warm. It is getting cold now.
Mother, warm clothes gives us warmth. In summers, we wear light clothes with light colors.
Yes, you are right. We wear light colored clothes in summers because light colors reflect the heat and hence we feel less warm. And in winters, we wear dark colors because dark colors absorb heat and hence we feel warm.